Alright, so here we are again, and we're going to talk about, in particular, with organic chemistry, hydrocarbons, and the three functional groups of that, which are alkanes, alkenes, and alkynes. Just a quick note, IUPAC stands for International Union of Professional and Applied Chemists. Okay, so a hydrocarbon, basically, they're a subset of organic compounds, okay, and they can only contain atoms of carbon and hydrogen. Now, organic compounds, we said, can contain chlorine, blah, 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 but the main branches of this will only contain carbon and hydrogen. So there are three families. There are alkanes, alkenes, and alkynes. Each family is called a homologous series. Homo, in this case, means the same functional group, which the functional group is a group of atoms that are common to all members of that series. So you could have butanol. No, actually, no, we won't get into that just yet. So functional group means a grouping of atoms which is common to all members of that series. And basically they can be recognized by a general formula. For example, the homologous series alkane has the general formula CN2H2N plus 2, and the functional group is single bonded carbon. Alkene, double bonded. Alkyne, triple bonded. Now, this means for every alkyne, it has at least one triple bonded carbon in there. Now, if we have a look here, here's the generalized formula, and you'll see that when we start to name them in a minute. Alright, alkanes. Basically, they increase in size by CH2 as you go down the series. So here we start with C4, extra C with an H2, extra C with an H2, all the way down. They are saturated hydrocarbons, which means they only have single bonds. They are non-polar, but can have polar forces as we come in. Okay, now when they are close together, you can get dispersion forces, weak dispersion forces, which means the local migration of the random migration of electrons around the atom or around the molecule means that you might very quickly get an area which is, polar, non-polar. They then they get attracted to each other, and that pushes them out further. This is a dispersion force. Okay, this kind of holds, we'll get into that more in a minute. So they have intramolecular bonds. These are strong covalent bonds. Intermolecular bonds are weak dispersion forces, and these are the ones that we break when we change states. So basically, as the molecule increases in size, the melting point and the boiling point increase. So the smaller they are, the more volatile. The smaller they are, the more easily they react. And that's because of these dispersion forces. The suffix is ane, A-N-E, say ethane, methane, blah, blah. Alkenes. Alright, so each one has one or more carbon-carbon double bond. They are unsaturated because of the double bonds. So this means that something else can react there. It's not saturated, it's not filled up. Something is saturated if it is full. The double bonds make alkanes more reactive than alkenes more reactive than alkanes. They have the suffix ene. If we get but this is our list here, by the way. And you see each one has a double bond in its structural formula. Alkynes. So basically each one has one or more carbon-carbon triple bond. All of the ones we have here have only one triple bond. They are unsaturated because of the presence of the triple bonds, and this means that there's more that can react there. They are more reactive than alkanes. More reactive than alkenes too. And they have the suffix -ine. Alright, how do we name them? And here we have three, which we've sort of named here. Ethene, propene, 1-butene, 2-butene. We'll get to that in a second. So according to the IUPAC, they are named systematically. And this means that you're able to just know the name of it. You should be able to draw it. Now, that's a bit trickier, but you should be able to draw it based on just the name. So the prefix, that indicates how many carbons are in the main chain. Okay, for example, meth is 1, eth is 2, prop is 3, and it goes so forth down. butane, pentane, hexane, heptane, octane, and that's up to 8. The suffix, this indicates the homologous series that it belongs to. Ane, ane, ene, ine, yne. So if the functional bond is a double or a triple, right? If it's at the beginning, we can place 1 or n at the beginning of the word. So here we've got the double bond, double bond, double bond. You don't have to. You can, so it's 1 for the first one or n for normal, but you don't have to. If the triple bond or double bond is beyond the first number, you do it at whatever's going to be the earliest. So in this case, you can go 1, 2, 3, oh, sure, and that would count. But you go 1, 2, or 1, 2, you go for whichever one's going to be give you the lowest number at the front. That's 2-butene. So but for 4, 1, 2, 3, 4, 2 because the double bond happens there, and ene because it's a double bond. Alright, so let's have some properties of alkanes and alkenes. The physical properties, they're fairly straightforward. They both have low boiling points, and that's because they're only held together as liquids by weak dispersion forces. The chemical properties, however, the combustion, they both burn in excess oxygen to form CO2 and H2O. So for example, ethane, and you'll be able to see something from their reactions here in a minute. Ethane, you've got two ethanes plus 7 oxygens give you carbon dioxide plus H2O. That's what you get if you have excess oxygen. So if the limiting reagent in this case is ethane, you will get that. If the limiting reagent is if the limiting reagent is oxygen, you'll start to get carbon monoxide or carbon and other products which aren't, which means it's not burning as cleanly. Ethene, you go C2H4 plus 3O2 gives you 2 carbon dioxides and 2 waters. Now, alkenes are more reactive. So this means they can undergo addition reactions, whereas alkanes can only undergo substitution reactions. So let's have a quick look at that. Addition versus substitution. So alkenes, they can go through addition reactions with hydrogens and nonmetals, and that's because they are non-saturated, they are unsaturated. So the double bond breaks, and they can just slot right in where it's at. Addition reactions can only occur with unsaturated bonds. Alkanes, on the other hand, they're unable to undergo addition, so they are less reactive and have to go through substitution. For example, if hydrogen bromide comes into ethene, we see that bond breaks, a hydrogen joins up here, so you've got 2 here. There's your 2, the hydrogen breaks, the double bond here, it's broken, and now, so this hydrogen has joined there, and this bromine moves up here, and now we have, that would be, by the way, 1-bromo ethane. Now, here we have chlorine gas. So we're going to have a comparison here. So we have ethene being added to chlorine gas. And what we get is 1,2-chloroethane. Okay, so this bond here breaks, which means that's got an electron, that's got an electron. It shares with this electron, and gives you this structure. Now we get a substitution reaction here, because this is an alkane, which means it doesn't have the space to react. Alright, it doesn't have the extra valence electron that's easy for it to split. So we get the ethane, it comes along, here's the chlorine gas, we put it's got to have a catalyst in there, and you get you get 1-chloroethane plus hydrochloric acid. You get the substitution. So what you get is this one here and this one here, swap over, substitute. That's it. I hope that makes sense. But be prepared to rewind, pause, go back through it, and we'll see you in